This is r.d.sharma solution class 12 chapter 19. Exercise is 19.20. Indefinite integrals we are talking about. Now this type of questions, there is a separate way of doing it. We will try and we always try to get something out of the denominator so that we can get the numerator, or vice versa. This x square minus x, you need this x square minus x in the numerator. So write this x square minus x and then do something so that you get x square minus x in the numerator along with other terms. So just write x square minus x. You already got the x square. Since it is x and you have negative x here and you need a positive x, for that you have to add a 2x here. So 2x minus x will be x only. Now plus 1 is already there. So why we have written this? Because we have got this x square minus x in the numerator. So now when you divide this x square plus x plus 1 divided by x square minus x, this x square minus x will be 1 and that will be 2x plus 1 will be separate and denominator is x square minus x. So this whole numerator has become x square minus x plus 2x plus 1. We have divided it by x square minus 1, x square minus x, separated these two terms. So 1 plus 2x plus 1 divided by x square minus x is the final way where integration is easily possible. So the integration, let's proceed with the integration. The first term is only 1. So it will be 1 dx. The second term is 2x plus 1 divided by x square minus x. This is our second differentiation, integration. So this is integration, two separate integration we are doing. Now for the second term, first term is simply x. How about making this x square minus x in the same way we have done in the previous exercise? I am suggesting that is the first integration will be x. The second integration will be done in the way we have already done the previous exercise. That is 2x plus 1 has to be represented in the differentiation form of the denominator. That is a into d by dx of x square minus x plus some constant b. So that we can separate these 2x plus 1 also in two terms. Easily integrable. So just take this x square minus x differentiation is 2x minus 1. Now just compare the similar terms. So a into 2x is 2xa. So minus a plus b. 2xa will be equal to 2x. If we compare the similar terms, b minus a is 1. A is 1 from the first one and this b is going to be 2. So this I am calling it as say I1. First x is already there. We'll use it later. This differentiation which I am talking about, in the equation a into 2x minus 1 plus b, just put this a and b and separate them out with the denominator. So the first term is a into 2x minus 1. Okay. So 2x minus 1 will remain in the numerator. 1 is there, so we don't worry about that. Denominator will be x square minus x. How about the second term, which will be b? B is 2. So 2 I am taking outside. Integration of dx divided by x square minus x. So this first one, which let us call it as say I2. The next one we are calling it as I3. This I2 will be quite easier because we have completed the previous exercise. Just take t equals to x square minus x. dt will be equal to 2x minus 1 into dx. So dt is 2x minus 1 into dx. This whole numerator will become dt. X square minus x, we have already taken it as a t. So it will be dt by t integration. And what is the dt by t? It's simply log modulus of t plus constant of integration. Log, what is t here? X square minus x plus constant of integration. Call it as c1. So this is the first integration of the first part. Now the second part we are doing, which is dx divided by x square minus x. This x square minus x, we have to make it as a perfect square. So what is in front of x? 1. Now divided by 2, it will be 1 by 2. Square it, add it, subtract it. That is plus half square and minus half square. So a square plus b square minus 2ab. So this will be x minus half whole square. This is the first term. And this will be negative 1 by 4. So you can call it as 1 by 2 whole square. So this integration will become something like this. Dx divided by x minus half whole square minus half whole square. You already know the formula of dx by x square minus a square integration. This will be 1 by 2a, that is 1 by 2 into 1 by 2 log x minus, it will be x minus half minus half, and denominator will be x minus half plus half. So x minus a, x plus a, we have formula we have used with the constant of integration c2. So there is a 2 here. Let's include this 2. This 2 gets cancelled, so 2 will remain here. So let me write the final answer, and this x was already there. So let's collect all the things which you have done separately. So x plus I1, I2 which I call as log modulus x square minus x plus c1. The second term is plus 2. Let's resolve this now. So this gets cancelled in the denominator. X minus half half plus half is 1. So it will be x minus 1. Denominator will be x minus 1 divided by x plus constant of integration c1 plus c2. You can combine it as c. So this is the way you are going to solve it. X square minus x can be written as x into x minus 1. So log a into b, log x minus 1 by x log a minus b, that also can be done. X square plus x minus 1 divided by x square plus x minus 6. This is x square plus x minus 6. We would like to represent the numerator in the form of denominator with some addition or subtraction, so that we can just cancel out x square plus x minus 6 from the numerator and we get a separate term, and they both are easily integrable. So what we'll do, we need this, we just write x square plus x minus 6 of the numerator, and then we add up 5. Why we added up 5? Because the numerator is of course x square plus x minus 1. It has to be that only. So we have x square plus x minus 6 in the denominator now. So we have added 5 in order to make it as x square plus x minus 1. But x square plus x minus 6 remain there because we want to cancel it out with the denominator. So we need to separate these two terms out. You'll see the difference when we separate them out. X square plus x minus 6 divided by x square plus x minus 6. Now separating this 5 alone, 5 divided by x square plus x minus 6. Now this is the actual formation. This will be 1 because this gets cancelled. 5 divided by x square plus x minus 6. So let's write it in the integration form, integration of dx, 5 into integration of dx by x square plus x minus 6. So this will be x, we'll use it later. And this is the second term. It's quite easy because x square plus x minus 6 just has to be made as a perfect square. How to make it as a perfect square? X square plus x minus 6, take the coefficient of x which is 1, divide it by 2, that will be 1 by 2, square it and subtract and add. So half square minus half whole square. So we have a square plus b square plus 2ab, x plus half whole square it will be. Then you have 6 and 1 by 4. So you just take the negative outside, you can add them, 6 plus 1 by 4. So 6 4s are 12, 12 plus 1 is 13, 13 by 4. No, 6 4s are 24, 25 by 4, sorry. So 25 by 4 it will be. So this is 5 square by 2 square. You can write it as 5 by 2 whole square. So we have made it as a perfect square now. And now we can use the formula directly. I am doing this one. So this is dx by x plus half whole square minus 5 by 2 whole square. And this is what? Dx by x square minus a square. So 1 by 2a, 1 by 2 into 5 by 2 log. So x plus half minus 5 by 2. First of subtraction, x minus a and x plus a. So x plus half plus 5 by 2 now. In the modulus sign, don't forget about the modulus sign. 2 gets cancelled. I told you 5 was already there. So 5 also gets cancelled. So nothing is remaining in front of this log. So just add this log. Now let's resolve this. Half minus 5 by 2. What will be this? This will be negative 4 by 2, that is negative 2. Denominator half plus 5 by 2 is 6 by 2, that is 3. So we have numerator as x minus 2, denominator as x plus 3. And this is in the modulus sign plus constant of integration. And this is integration which is the final result. Okay, this one 1 minus x square by x into 1 minus 2x. So this will take an effort. That is 1 minus x square, let us write it as negative x square plus 1. First thing is this one. So this x minus 2x square is the denominator, right? Let us write it as negative x square plus 2x plus x, because we have just multiplied it. So negative 2x square plus x, which is actually x into 1 minus 2x only. And 1 minus x square was written as negative x square plus 1. We need a negative 2 in the numerator. So multiply 2 and 2 in the numerator denominator. We have negative 2x square plus 2 in the numerator. And when you multiply this denominator with 2, don't multiply it right now. Let's first separate them out, or make this negative 2x square plus x appear on the numerator. So minus 2x square is already there, plus x is already there. Plus x was not there. So we are adding x and subtracting x. 2 has come because we needed what? 2 was multiplied earlier. If you remember, 2 multiplied and divide earlier. So negative 2x square plus x divided by negative 2x square plus x. How about this one? So 2 minus x. 2 minus x is remaining now. 2 minus x divided by negative 2x square plus x. So this will be 1 minus. So if you want, we can make it as a plus. You can keep it as negative only. But just to deal with the positive sign, I am making 2 minus x as x minus 2. I have taken negative common from 2 minus x. So negative negative gets cancelled. It will be 1 plus integration of x minus 2 divided by 2 negative 2x square plus x dx. So we'll deal with this x later, or write this later, because integration of 1 dx is x only. Now negative 2x square plus x. So x minus 2 has to be written in the form so that we can have a differentiation of the denominator. That is a into d by dx of negative 2x square plus x is the first term, plus capital B. So this will be x minus 2 equals to a. Differentiation of negative 2x square plus x will be what? It will be negative 4x plus 1 plus b. So multiply this, negative 4ax plus a plus b. This will be x minus 2. Now equate the similar term. So x will be equal to negative 4ax, and the second term will be a plus b equals to negative 2. So this x gets cancelled. A will be equal to negative 1 by 4, and this negative 2 will be equal to negative 1 by 4 plus b. This b will give you 1 by 4 minus 2, 1 minus 8 by 4, which is negative 7 by 4. Now the integration will be done like this. I'm just taking this equation number 1, putting the value a and b, and then separating the denominator out. That is negative 1 by 4 is a, negative 4x plus 1 divided by negative 2x square plus x. Then we have negative 7 by 4, and this b, which we have taken outside. Integration of denominator will remain negative 2x square plus x. This will be dx, and this will be dx divided by negative 2x square plus x. Now this will be I1. Let's do this I1 first. Negative 1 by 4 and negative 7 by 4 will deal later. Half was already there. Remember, we have divide the denominator earlier with 2. So 1 by 2 is already there. Negative 1 by 4 is already there. We'll deal it later. So we'll take t equals to negative 2x square plus x from the denominator. Dt will be equal to negative 4x plus 1 dx. So the numerator will become like this. dt divided by t integration. So this will form what? Log modulus of t plus constant of integration, call it as c1. Log t is actually negative 2x square plus x. So minus 2x square plus x plus constant of integration c1. So we have to multiply it by minus 1 by 4 and also 1 by 2. 1 by 2 is already there outside. So we'll deal those constants later. But we have to do this dx by negative 2x square plus x now. Now there is one more thing here. Negative 2x square plus x has come from where? If you remember, it has come from x into 1 minus 2x. So you can write it as log inside this. Let me resolve it. So it will be log modulus. This negative 2x square plus x has come from here. X into 1 minus 2x is negative 2x square plus x. So this will be x into 1 minus 2x, original thing. So you can write log a into b as log a plus log b. So you can write it as log modulus x plus log modulus 1 minus 2x. This is your first thing. Plus constant of integration c1. This is your, call it as this one, which we have done. The second one is dx by negative 2x square plus x. So we have to make this negative 2x square plus x as a perfect square. So for that, negative 2 you have to take outside. So it will be x square and minus x by 2. Just take negative 2 outside, whatever is there inside. Keep it like this. Make it as a perfect square. So you have a half here. Divide by 2, it will be 1 by 4. Square it and subtract and add. So 1 by 4 whole square minus 1 by 4 whole square. So x minus, see, a square plus b square minus 2ab. So x minus 1 by 4 whole square is these three terms have formed x minus 1 by 4 whole square. 1 by 4 whole square is already there. So this integration will become like this. I'm making a formula of x square plus a square now. So dx by x minus 1 by 4 whole square plus 1 by 4 whole square. And please remember, already negative 2 is outside, negative 7 by 4 is also already outside. So 1 by 2a log x minus 1 by 4 minus 1 by 4, and denominator you have x minus 1 by 4 plus 1 by 4. So denominator 1 by 4 and negative 1 by 4 get cancelled, so only denominator will be x only. The front, you have 2 here, you can just cancel it out. Don't forget about this negative 7 by 4 and all those numbers, okay? So first term is x, second term is log modulus x plus log modulus 1 minus 2x plus c1. So 1 by 2 is already there. 1 by 2 comes here also. So all the constant terms you have to be very cautious about, because there are various constant terms which will come. So I'm multiplying all the terms here. Minus 1 by 4 with this term and negative 7 by 4 with this term. So all these you're seeing. But there is one more thing. Log x minus 1 by 4, 1 minus 1 by 4. Let me resolve it first. It will be x minus 1 by 4 plus 1 by 4. That is 2 by 4. That is 1 by 2 only. So x minus half. Denominator, this gets cancelled, so only x. So this will be 2x minus 1 by 2x minus 1 by 2, and there is x also. So now log a by b, log a divided by b is log a minus log b. So log 2x minus 1 minus log 2x plus constant of integration. Now these are the three terms I separated out for you. And then see all this clutterness, let me show you the actual answer. So let me write the final answer. X was the first one, half was already there, so x by 2 log x minus 3 by 4 log modulus of 1 minus 2x plus, there are two constants, remember, so call it as capital C. All these have come from the constant multiplication and the cancellations. So let me show you how you are going to go about it. We have done it, I explained you, but there are certain things which are very deep here, which will come only when you calculate it actually on paper using a pen. So these all values which you see here has come out of that result as a consequence, and we combine them and finally came to a conclusion. This we are going to take in the next discussion. Till then, thank you so much and take care of yourself.